This is continuation on 11-1, and what I'm doing is example 11-2 in your book. A Census Bureau of U.S. government found that 13% of adults did not finish high school, 30% graduated from high school only, 29% have some college education but did not obtain a bachelor's degree, and 28% were college graduates. So this is something that a Census Bureau gave me, these percentile. Great. To see if these proportions were consistent with those people who lived in the Lincoln County area, so now we want to take a specific area and see if it matches with the Census Bureau. What we have found is a local research selected a random sample of 300 adults. So just right there, I want to outline the fact that n is equal to 300, and found that 43 did not finish high school, 76 were high school graduates only, 96 had some college education, and 85 were college graduate. At alpha of 0.01, test claimed that the proportions are the same for the adults in the Lincoln County as those stated in the Census Bureau. So what we are doing is the 300 isn't split up evenly into the categories that we're interested in. We are actually expecting a certain percentile. So let's break up these categories. What we have found is no high school. This is my first category. The second category is high school only. The third category is some college. And the last category is bachelor degree. Or graduates. That's the one. Graduates. Okay, so the expected is the one that is usually given to you first, because out of the 300 adults, we found, so that's your, no, that's your observed, I apologize. Your observed is the one that's given to you within the sample, because you observe it. So we looked at 300 adults, found that 43 did not finish high school, so 43 goes into this category. The next one, 76 were high school graduates only, so this is the number that goes in the second category. 96 had some college, so this is the one that goes here, and 85 were the college graduates, so this is the one that goes in the last category. Now the expected has to do with the 13%, 30%, 29%, and 28%. Those are my four categories. Now, if I survey 300 people and I am looking to expect around 13% to be the adults who did not finish high school, I need to take that 300, multiply it by 0.13, and I will get the number out. In reality, the expected value does not have to be an integer, even if you're talking about people. So let's take a look at the next number. 300 times 0.3 is 90. Now, deceiving, the example in the book does show you everything is a nice integer. That usually doesn't happen. The sum college is the 29%, so you're going to take 300 and multiply by 0.29 to get 87 for the expected in the next category. And as far as the last category, I'm expecting 28%, so I'm going to take 300, multiply by 0.28. I am expecting to see 84%, not 84%, 84 people. So notice this number is awfully close. This one's a little off. This one's a bit more off, but this one's kind of close again. So, well, let's run the test. Before I run the test, state the null and the alternative hypothesis. The null hypothesis, I need more space than that, but the null hypothesis will basically state the percentages. So the expected or the proportion of people in each categories is as follows. And you're basically stating what the original problem said. 13% did not finish high school. What was the next one? 30%. Well, high school graduates only. %29 had some college. And 28% were college graduates. The alternative hypothesis is the proportions are not as listed above. Something is wrong. Something is different. The truth of reality is, even if we do reject the null hypothesis, we don't know what category is responsible for that. So a lot of these tests, you'll find that you do not reject the null hypothesis. So let's run this test. I will go through this problem by calculating the chi-squared. What you need is to find the difference between the 43 and the 39, square that, and divide it by the expected. Do the next problem, 76 minus 90, square that, divided by 90. Next one, 96, not plus, minus 87, squared, divided by the expected. And the last one is 85 minus 84, squared, divided by the expected. Not E, the expected, 84. Put all of that into your calculator. You will find that 3.531 is the appropriate chi-squared test statistic. What you can do at this point is, if you do have a TI-83, go into the distribution, find your chi-squared CDF, put the lower bound, put the upper bound, and the degree of freedom. Now, we again have 4 categories, so 4 categories minus 1 is 3. This is something that you want to put somewhere in the vicinity of the problem that you're working on, and get the p-value this way. 0.317. So 31% is not a tail. So the p-value is equal to 0.317, which is certainly greater than any alpha that could possibly be stated in the problem. The alpha that they use is 10%, so even a huge tail like 10% still doesn't allow us to reject the null hypothesis, because the p-value is at 30-something%. So it's not a tail, it's a chunk. So do not reject the null hypothesis. So we did not find enough evidence to reject the claim that the proportions are different. Not enough evidence. To observe or to state. That the proportions are different. Different from the, and if you'd like, you can copy this over, or you can say from the statement of census bearer. This does end 11-1, and I will show how to do this on the calculator in the next video.